Hello everyone. I wanted to respond to your comments on the discussion board, and first of all, thank you for posting them. Lots of good thoughts and ideas. Let's start with the first one on coding and problem solving. What does that have to do with writing code? So, if you look at this, what I've got up here, we've got what we think of as this problem solving process. It's pretty straightforward. You have to define your problem, you have to prepare to solve it, gather everything you need, and then you have to try it, and then once you're done, you reflect on it and make sure everything's working and you're good to go. In reality, of course, it's a lot messier than that, and it's a process that we call recursive, or a process that doubles back on itself and goes back and forth, not linear in one direction. I'll give you an example. I recently replaced the graphics card on my computer, and at first the process seemed to be going like is showing up on with the arrows here, pretty straightforward. I define my problem. I've got to take out the old one, put in the new one. I prepared by I looked up videos on how to do it, read the instructions, and then I tried. I pulled out the old one, put in the new one, and then I reflected by checking on it and finding that the computer wasn't working. And so I had to kind of go back and from that reflection I had to go back and do more preparation, which involved research, trying to look up, okay, what kind of problem am I running into? What does this mean? I actually contacted my cousin, who's an engineer and knows more about computers than I do, and he actually helped to really solve the problem. But going together, we actually had to go through and try out a whole bunch of different stuff. One thing we figured out was that I had accidentally unplugged a cable to a hard drive um, into the power supply, so it wasn't getting power, and that was throwing off the computer's boot process and all this stuff. So that redefined our problem. Had to then do more preparation, looking up different things and researching how to fix that and trying out a whole bunch of different stuff. It took forever, and finally solving it, and now I'm using that very computer and graphics card to make this video right now. So in reality, the problem solving process is messy. But the point is, if you're going to write code, you need to be prepared to do this, and what I want you guys to remember is, one, especially that reflect piece at the end. You don't just write your code and then throw it in and say, okay, I'm done. You got to reflect on it. In coding, that usually means checking your code. If you don't check it, then you are going to end up with buggy code. Everyone has bugs in their code at some point, especially for those of us who are novices. So you got to reflect, and then you've got to be resilient. You got to keep trying. If it's not working, then you have to do more preparation. That might mean research, looking up what your problem with your code might be, or finding out more about how to use coding language. In our case, we're going to be using HTML to express what you want and to make it do what you want. Maybe looking at examples of proper code, or asking someone who knows, maybe a neighbor or friend who knows about coding. You could ask me, of course, but you keep trying and trying and trying until you figure it out, and you will figure it out. It takes a while, but you can learn it. All right, so problem solving, writing code, yes, let's do it. Let's talk about the second and third question. So I asked you, is a pencil sharpener a computer, and is a car a computer? Interesting answers I saw. I think we can all agree that a pencil sharpener is not a computer, but let's talk about why. What is a computer? What does it do? Well, remember, a computer does four basic processes. It can take input. Usually that'll be something coming in from the keyboard or the mouse. It could also be a microphone or a camera. Those are the most common ones, and you might have other kinds too, but that's pretty much it. And then it takes all of that input as data, and it processes it. This is where the CPU comes into play, and this is where a computer performs all sorts of complex calculations and stuff. It could be something really basic, like an addition problem, or it could be something really complex, like, say, running the graphics for a very sophisticated 3D video game, or Bitcoin mining, or other stuff. Anyways, it's got to be able to process information or data. It also has to be able to store data. As it's processing, data will be temporarily stored in the memory. data is also stored in the hard drive and long-term storage, but it's got to be able to keep information in there. And then, of course, when it's doing all this, it then has to be able to spit that information back out as output, usually through a monitor, a touch screen. It could also be through a speaker or a printer or a combination of those outputs. So these are the things a computer does. If it doesn't do any one of these steps, if it doesn't do all four of them, it is not a computer. Think about a pencil sharpener. It takes input, a raw pencil, it can process it, you put it in there, it sharpens it, and when you take it out, it gives you output, a sharpened pencil, but it doesn't store. So by that alone, it's not a computer. You could probably make an argument that even if you could put a pencil in there and store it, it's still probably not a full-on computer, since we are the ones having to kind of, do it. I think there's something to be said for automation in computers. The fact that I am processing it or having to put it in and pull it out. Anyways, pencil sharpener, definitely not a computer. Now, how about cars? Well, a traditional car, we can be pretty confident in stating that it's not a computer. Yeah, it can take input. True, I can push down the gas, for example, and then it will do something with that. I guess you could call that processing. The engine is doing combustion and moving the drive shaft and so forth. Anyways, and then the output is movement. But again, there's no storage. You're not processing and storing information. It's really a car. A traditional car is not a computer. Now, many of you pointed out that modern cars are chock full of computing systems, anything from sensors that will take readings of the car's systems and if they're functioning properly, to things like a GPS and kind of onboard computers. In that sense, if you want to look at it that way, we could say a car is definitely a computer. These things take input, even a sensor. It takes input from the engine. It can process that and determine whether it's functioning properly or not. It can store it until a mechanic then hooks into it and takes a readout where it gives output. So that's a computer. And then, no question, things like GPS would be a computer. Now, you can make an argument, well, no, a car is just a car that has computers in it. And, that I'll leave that to you guys. Is a car a computer, or does it just have computers in it? Up to you. Either way, though, we know what a computer is and how a computer works. Here's one more for you. How about an abacus? An abacus, as you see in the picture here, it's a framework of beads that was used anciently, and in fact they still used in some areas today to make calculations, and they can actually go pretty quickly in the hands of a skilled user. Can it take input? Well, yeah, you move the beads around. They symbolize different numbers and different sets of numbers. Can it process? Well, there's the argument, right? You're definitely processing numbers, but of course it's human assisted. We're the ones moving the beads. It can store the information for sure. When you leave the abacus there, it leaves the calculation for you, and then the output, you could say, is, if you can read an abacus, it's the number that you're interpreting from it. People will tell you that an abacus is the earliest form of computer. My own opinion is that it kind of is, though it's a computer with a human assist. It's not automated, and that kind of leaves me to say, well, it's not a computer in the modern sense of what we're talking about. Some of you just in the discussion talked about how things that don't have a CPU aren't a computer. I'd say that's probably a handy rule of thumb, but it's not necessarily always true. All of the earliest computers from the late 1800s into the 1900s didn't have a CPU as we would recognize it. They did have programs and processes to process, but they were done by other mechanisms like punch cards and vacuum tubes and other things. So, anyways, there has to be some thing that processes. Pretty much anymore, it's always going to be a CPU, but there are exceptions to that rule. So, anyways, thanks for sharing your thoughts on all of those questions, and well done.